Perhaps we better start from the beginning. As I said in the Rob Zombie song, Astro something or other, I don't remember what the name of the song was. So I was told by the owner that he bought this off of Fleabay, and it is really, 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 really rough on the inside. And he says, don't be in shock and awe, but what I want you to do is make it into a BBI box. Oh, yeah, it doesn't look too bad. Four Toshibas in it. All the same lot. It's got the right caps in all the right places. Little undersized relay in the back. But this does not. I've made way worse look a whole lot better than this, but this isn't all that bad. I feel like that run-on strung together sentence. So this bottom one is an OB, an 08. And then the rest of these are 1D, OD, and OD. I'm talking about the lot numbers on the transistors. Well, something's amuck because our output resistor here is gone. Let's run it through its paces and see what's dead. So there's a little bit more to this. We got multiple amps that we got to fix, and this guy was cool enough to send up like 12 of his own Toshibas that are straight from RF parts. And I'm glad he did. Now I start looking in here. Let's get down in here. And we're gonna let our eyes relax a little minute. See if I go to manual, if I can get this to play better with others. There we go. Okay, so let's take a look at this transistor's foot. And what we're looking at is underneath the screw. You see how it's got that flat edge? That means it's real. The Chinese haven't bothered to copy that yet. Then what we'll do is we'll look over here at this transistor's foot, and it is round. It's got a curve to it. The other thing that sets this apart from the other transistors is the Toshiba print. Look at the print here versus the print here with this next door partner, or its print here with this next door partner. I see what happened now. These two transistors are the original OGs. Some point or another it got popped. If we start and we look, we will see that if we look at this resistor here, let's look at the print that's on it. See how thick that third band is? The thick and thick. See that? Skinny. Solder splash. This one's used. This one was in here new original. You can tell by looking at the solder work. This has all been changed out at one point or another, but this one here, let's look at the epoxy that holds the lid down. This white stuff, this white stuff right here. See that? There's just the print's wrong. An 08 or OB. That's got a 0B. Okay. We'll go with it's a 0, not an O. Anyhow, this is a fake pill slammed in here with a used pill. So these two transistors have got to come out, which that's not a big deal. Like I said, we've got lots of parts to stick back in here provided by the customer. These are not coming out of my personal stash of almost 1,000 or whatever. So yeah, I think that at one point or another it had a pill get popped and they took it to somebody that didn't know what the hell they were doing, or they did know and they tried to scam out of some money or something. I bet you that pill's now fried and that one's probably on its last legs, but this is a Chinesium copy. That's a real one that was slapped in here. Kind of obvious. Let's pull the pills. Let's see what the deal is. Okay. Let's see. I got audio. Okay. So I stripped it down. Everything's out of here I don't need. I was talking with the customer. He decided that he wanted to do this one plus the other one. Convert them into 4 pills, straight 4 pills. Now, he sent up all those transistors and he says, well, let's go ahead and strip them down to the bare bones and let's do fresh restart. So we're going to put brand new fresh Toshibas in here. I took out the relay because it's too small. I'm going to upgrade it to a bigger one that actually do the job. I took the caps out because we're going to need some room to work, and the caps are kind of obsolete with the use of super caps now. Let's go over here. Let's look at our transistor selection here. The used parts that came out. This is the used transistor, or the fake transistor. Let's run it through its little gambit here. HFE gain is 16. Okay. That's his paired partner. So technically those are both still good, but they're 2 different parts, so we'd never run those together. Even though one says Toshiba 2879, the other one says Toshiba 2879. They're fake. This has got an HFE gain of 6, so it's almost done. That means this one's not far behind it. Gain of 24. Okay. Well, is what it is. They're not going to get used again, so it doesn't really matter. Let's see here. Let's go over here to the El Bago parts. See, in the beginning, when you would order a bunch of the transistors from RF Parts, they'd come to you in these little flat containers. And then that was taking up too much space, and then they started selling them to us in baggies like this. So just randomly grab one of the 3 sets here, because it doesn't really matter. And I'm glad he decided not to do this with HGs, only from one perspective. Oh yeah, 1K. I build a lot of good boxes with these. I'll have to pull the whole amp apart, pull the board out, and Dremel out the holes for the different size foot. Yeah, it's got a gain of 86. Never got them in individual baggies like this before. That's odd. These are legit. $85. Love them high gain numbers, man. $81. 79. Okay. So these two are together and those two are together. Let's keep those separated for a hot minute. Okay, so now what we're going to do off camera is we're going to give this thing a bath. We're going to wash out the pill pockets. We're going to get down to bare metal. We're going to make sure that our holes for our pill screws are countersunk, counterbored, however you want to look at it, so that we can give these precious little gems the best chance of survival that we can give them. Come back, we're going to put some thermal coat underneath the transistors. We're going to screw the whole mess together. So let's go do the nasty. I've been doing this more and more and more. Just over here building and taking care of business and doing the phone bit, and it dawns on me, shoot man, you're almost done. You got to shoot a little YouTube segment so everybody in YouTube land can follow along with the story. Otherwise we would have left off with, oh yeah, we're just going to wash it. So we washed it, and I put down the 4 new transistors. As you guys can clearly see, they're all matched beta gain, blah, 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 blah. I went ahead and built up the bias circuit, as you guys can see. I reused the 5 amp relay that was the transmit receive relay and utilized that to switch the bias circuit on and off. I put the new upgraded relay in it, 10 ampere in here, and I also wired in the sideband delay, mounted the sideband bias resistors, and got the power wire board kind of unmugged. So this and these and all of this, and undid this, and down here in the front it's got a new switch. I'll make sure to put a SSB label on it. It's just gonna get cluttered in here really quick. So we're going to have our flybacks in here, which I'm building over here. Obviously, we're going to replace this, which goes here. And then I do a power wire distribution upgrade, a little power wire upgrade. We'll put that in here real fast. And let's see, I need to scoot over just a hair, like right about there. Then it'll be time to test it. So just cruising right along, making progress. I'll be back. Well, I literally put everything plus the kitchen sink in this thing. So the sink's completed. Yeah, so let's go over here. Let's look at this. We have a 1,000 watt slug here in peak envelope power, 1,000 in average, 5 watt slug in reverse back from the Bird 10,000 watt dummy load. So now what we're going to run today is the 955. And we're going to use this 5 watt slug in reverse to show input tune. So first, let's start off with input and output tune. Let's just start there. Let's grab the microphone. Let's turn the amp off. Everything's perfectly happy. Now, we're going to look at this and it's going to pop up to about 1.5, but watch what happens when we modulate and watch what happens here. Hello, audio, 1, 2. It's perfect. Everything's happy. It's showing a little high here, but it's climbing forward here, but it's dropping on this meter. So we've got the best balance of both worlds. So if we see this meter jump up a little bit on your end when you hook it up to your derail, back the dead key down or see what it does with a little bit higher dead key. It'll be fine. Now let's go look here. Like I said, we're on about 15 volts. Show you what I'm putting into this for drive. Hello, audio. Full chooch, 125 watts. Hello. Hello. Doing about 1150 and some change, which is just about where we want to be. So I did change a couple other things so that they made sense to me. I'm sure in the DaveMade camp, DaveMade Moby camp, the way they do things makes sense to them, but to the rest of the world it doesn't. This is in, that is out, and when you flip a switch up, like every home electrical outlet or every switch ever designed, that is on. And I made sure to add a label for you. This is your SSB delay, and that means power on, power off. So I flipped the switch around so it's like ergonomically correct. Up means on. They like to wire things in reverse in the DaveMade world. I don't know why, but in their world, down is off. I don't know. So the only thing left to test is the fan and its voltage regulator, which I think this is cute because most of the DaveMade stuff doesn't have this kind of board done. So this is some kind of aftermarket thought. So let me go ahead and get this fan soldered in. And we're going to see if we can re-tap these PIM nuts because they had like Texas Star case screws holding the lid down. Let's see if I can get the real screws to get in it and fit. And if they do, we'll be in a totally kick-ass place, but let's make sure our fan works and we'll go from there. So, we're able to salvage all the screw holes, thank God. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Hello, audio. Under that old Model T was a place she first showed it to me. It's big and black and she called it her crack, but it looked like a manhole to me. So I pulled out my old power pole. It's good. It's good. Sideband AM, fully biased. Every bell and whistle I can throw at it. And right now I'm just grateful that they actually had the fan pointed the right direction. So, okay, so complete overhaul on this one's done. Now I gotta go look at a Fat Cat / Eagle Made / don't know. Same customer. So let's switch gears. You know, I don't think Eagle Made had anything to do with this. I think this was a cabinet that might have been bought from Eagle Made. But this is supposedly a Black Cat. We're gonna find out. I can't wait to get inside of this. I love this old school lamp, that's cool. Let's go dig into the guts of this and see what we find. It's supposedly a 500 VB-MG-1x4. It could be an H. I'm assuming it's an H. We'll go with the H, not M. Let's pop the lid off and see what we find. All right, now my guy's going, well, it's not the box that's in up there. Yes, it is. Got your note. It's inside the cabinet. Okay, so it says, Mr. BBI, please add 2 power supplies. 2x4 Toshibas. Make SSB. Off back ass board. Okay. Replace all bias. Add big transformers. Make it work BBI style. Amp was making very high SWR harmonics otherwise. Was a new build in an old box. Was told variable sounded bad. Was making just over 1K transmitted. Only worked for very short time, less than 20 minutes ever or less. Okie doke. What do we got on the inside? Well, as always, well, I can't say always. The last one of these I worked on, yeah, had the same tune circuit on it, and this is where all our harmonics are coming from. There's capacitors here and capacitors here. Yeah, it's just the circuit. There's enough power supply here with these transformers to make this happen, Captain, because we're going to abandon this one pill section. So I have 90 amps, 90, so this is a 30 amp module. Although we do have room for a fourth one, which I just might add because on sideband it is going to be pulling quite a bit of jizz. We'll look at that. We'll see how it works with voltage and current drop. Actually, I just lied to you guys completely and totally. There is no capacitance on the output tune of this box anywhere. These caps go to ground. This one and that one there, they go to ground. It's clean build. The tuning's off, that's all. The output resistor he sent in a bag. It's split in half. That was here. Wow. Okay. Well, let's pull all the HGs out of here and let's get ready to convert this thing over to Toshiba's. There's no 10 ohm resistor here. There's no 10 ohm resistor here. There's a 10 ohm resistor here and one here. So this whole section's missing its 10 ohms completely, although the solder posts are there. Well, it's got potential for great things. Clean work. Shame they don't know anything about tuning. Let's rip it apart. Okay, so let's be careful here. And let's be honest now. Over here, down in here, is a board that we would normally hook a tuning cap to. I'm assuming that this is what that's for. The thing is you got to compensate for the total surface area of this wire, plus the total surface area of the board, and then plus this total surface area above ground. So be careful of that. So, but there's no cap. That's the problem. And then we got this pretty well pulled down now. I'm going to pull the whole output side off too. We're going to change all this out as well. Might as well. Here's the input network right here. This whole section. This splitter is made of type 43. Each one of these input transformers is made of type 43. Now, they are slightly cheaper than the type 61, but this has a tendency to cause a lot of harmonics. We can get away with using type 43 transformers on the input for the most part, as long as this splitter is made of type 61. Well, when I seen this was made of type 43, these are type 43, these are all type 43. There's no point in even keeping those in the box. These output transformers are type 61, but the combiner in the back is made of type 43. These chokes are made of type 43. These little half by halfers, which that's fine. These are also type 43, type 43, type 43. Type 43 over here, type 61 on the output. And there's no choke to ground on the input transformer. So instead of me trying to guess what everything is, I mean, these caps are good. We'll probably reuse these caps. I mean, they're $9 a piece caps, so these are good parts here. And these transformers are technically good, but the customer wants a specific kind of build, so about the only thing that's going to be left of this, because we're not using this, we've bypassed this. No, we're not reusing we'll reuse the pull strips. That's about it, because that's what the customer wants. Over here on the variable, this is the input wire, just run across the cabinet. So we've got balanced, 50 ohm coax that's going up to a variable drive potentiometer, and then just a piece of 100 ohm wire going over to the input of the 1-pill section, which could cause all kinds of harmonics in its own right. So we're just going to abandon this. I pulled the power wire off for this. I'm just going to leave this just in case somebody wants to hook it up in the future. I don't know why they would want to, but we'll put a body plug up here in the front. And I just want to cover the ferrite mix, because this is going to go one of two ways. The person that built this box are going to take this as some kind of attack, or they're going to look at it as an opportunity to learn. Me personally, am looking at it as an opportunity to teach, not an opportunity to attack. This is a cabinet that was bought from another builder. We've confirmed that now. I've talked to the owner, and this was a Fat Cat build. It's an older one, so I'm just covering the basics. I've got, because now my name is going to be on this cabinet, I've got to guarantee that it is going to work and work properly. The other thing is there's solder splashes here for the 10 ohmers, splash here and a splash here for the 10 ohmers, but there's nothing been hooked up. They weren't there. So between missing these two 10 ohmers, don't know what that's all about, missing the output tune, really surprised it was doing 1,000 watts. 43, 43, 43. Yeah, I could see how there might be some SWR issues going on there. So, and it's not the amp that caused, well, hold on, back up. In this kind of situation, the amp can look really good on the dummy load. We can be making all kinds of power on the dummy load, but we're not going to know we're going to have a problem until we put the amp on an antenna, unless you own one of these. This is called a spectrum analyzer. This tells you where you're transmitting and roughly how much power you're transmitting at where. This is what this device, in a very dumbed down thing, very dumbed down terminology, that's roughly what this does. The old school way of checking it is your antenna. Your antenna, that I laugh when people say to me, man, that guy, he's got so much power, I can hear him from 160 meters through 10 meters. I laugh when I hear that, because your antenna will only let go through it a certain amount of frequency. If you think about it, your antenna is a trap for RF. Your tuning network inside the box is a trap for RF. So usually what happens is somebody gets so much signal on one frequency, the receiver on the front end of the radio gets overloaded, and so then they assume that that's what the person's doing, is they're actually transmitting on all the frequencies, and it's nothing like that. It has to do more with the fact that the receiver is completely overloaded. Now in this situation, what I'm getting at is your antenna, if you think about it, let's just all take and do a little mental exercise here. Your antenna is only going to be resonant from, like, if you're lucky, at this power level, you're going to have a fairly decent standing wave ratio on channel 1 and fairly decent standing wave ratio on channel 40, and you're going to have your lowest point in the middle of the band, channel 20. Okay? So your SWR looks like on a graph, it climbs up towards channel 40 and it climbs up a little bit towards 1, and its lowest point's at channel 20. If the amplifier is made with components that cause it to create a lot of spurious harmonics, like in the parts that deal with the RF if you use type 43 in the wrong places, when you look at it on a spectrum analyzer, you'll have dirt at like 50 megahertz and 40 megahertz and 80 megahertz and 70 megahertz and whatnot. But we're only talking like 10 or 15 watts. Well, how you see it on your meters at your station is because those are frequencies that are out of resonance for the antenna. That shows up as reflect. That's power that's trying to go out to the antenna, but it turns around and it comes back. And it shows up as reflect, because that's what it is. The RF wants to go out the antenna that's resonant. The antenna is resonant for just this little chunk of frequency. Anything that the amp produces outside of that is going to show up as reflected power. And most of the time it's just a poorly tuned antenna. But every once in a while it does show up where there's a lot of harmonics. Like I'm sure that this box here had some spurious emissions. I'm just going to say the last couple of these, and I've been through a couple of these. The tuning was set up where the amplifier ran like a Swiss watch on a bird meter, but when you looked at it on the spectrum analyzer, it was scary. Hold on, I got a call coming in I have to take. Sorry, I had to take that call. So you look at it on a spectrum analyzer and it's scary as frig. Now, 9 times out of 10, let's be very clear about this, it's usually not the amplifier creating all the weird harmonics. It's not. And your class of operation, like A, or class A, B, or class C, or class, like a solid state box is class B, it's not going to change how wide or how much frequency it occupies. This is not. The radio is 9 times out of 10 what causes the problem, the spurious emissions. 9 times out of 10. So if you've got yourself a setup and you're looking at it and you can't get the SWRs to come down, and when you modulate they drop to 0, but underneath the dead key they stay up there, 9 times out of 10, listen to me, 9 times out of 10, because I get this call probably 3 times a week. Man, I got this box and I'm trying to run it, and I got perfectly flat SWRs with my radio keyed up. As soon as I turn on that box, that SWR jumps up. Do you think there's a problem with the box? Maybe, and that's the honest answer, is maybe. Let's go ahead and try another radio. And they try another radio, and then they come back and go, oh, my SWRs stay down when the amp comes on. Okay, so what's that tell us? Well, there's a problem with the box. No. The radio that you're wanting to use is putting in a little bit of harmonic at some frequency. The amp is doing its job, it's amplifying it. It's probably at some obscure frequency that, the amp isn't really resonant for, so that way when you go and you modulate it, that little harmonic gets suppressed. Amp's doing its job. You put garbage in, it's going to amplify and make more garbage coming out, and it's showing up as reflex. Now, that 1% of the time, 1% of the time, it has something to do with the tuning on the inside of the box, or your ferrite mix, or how the box is constructed. 1% of the time. So please don't go away from this conversation thinking that you're now the RF amplifier whisperer. It's not. And with the advent of the waterfall on radios, you got to remember most radio waterfalls are only about 250 megahertz wide. So if you ask your buddy who's got one of them fancy dancy waterfall meters and he says, oh no, you look great on the waterfall, he's only telling you what you're doing in 250 kcs wide. If the primary harmonic that we have to chase and suppress comes from most radios is at about 56 megahertz. Okay, as an amp builder I know this. Most radios have a little kind of dirt that's produced because of the TVI trap and the failure of the proper tuning of the TVI trap in the radio. You'll get a little hash spike out there about 56 megahertz, 60 megahertz, somewhere in there. Usually it's 56, almost 52 to 56. We have to suppress that, or being leery of it, understand that it's going to be present when we go to do our tests based on the end user's radio. Now, what this guy's going to do is he's bought himself a derail. Well, derail makes some really squeaky clean radios. Contrary to what some other YouTube channels will tell you, I can tell you firsthand, I've never had one of them. I've got, 5 of them here now? One on this very workbench that I have to use as a tool of reference. They come out of there and they're squeaky clean. I've looked at them on, how many amplifiers have you guys seen me use the spectrum analyzer, and it shows nothing there. So I know that we're not going to have to overcome that phenomenon. But my job, and every amp builder's job, gain is 77, is to create an amplifier that for the most part is frequency quiet. It doesn't want to create any spurious emissions without having that signal being put into it. So how we test for that is we have radios that we know that are very clean on the spectrum analyzer, so then when we go and we pump signal into them, we see what comes out of the amplifier. This has got a gain of 78. So those two will go together. Gain is 78. The moral of the story is this. I've never had them come in these little individual bags, but these things are the real deal. The moral of the story is this, and the reason I got off on this tangent is because I'm trying to use this as an opportunity to teach, and I don't want to be attacking. I'm not attacking. And if somebody tries to say I'm attacking, you're a child, sir, and quit trying to start shit. It's not worth it. Is you use 43 on the power wires, the fans, like here for chokes. In the amplification stage, use 61. Input transformers, output transformers, your combiner, your splitters, use type 61. And you only want to add capacitance in one spot in this particular form of build. The guy that built this box is notorious for having his combiners where he's got capacitors on each one of the outputs of the transformers at the combiner and nothing on the final stage. Well, even if those two caps are measured with a capacitance device, there's going to be a slight amount of deviance between the two the two cap banks. It's like 1%. There's no way to get around it. There's just it's impossible. Unless you've got some weird connection, $7,000 a piece military grade capacitors that have been made for some military research project that are balanced within 1/1000th of a percent of each other, or NASA caps or something. This will never work, that form of tuning. So you're always going to have one side that's going to have a little bit more capacitance. The other, that throws things just a hair out of resonance, and that causes harmonics. Hence the reason that we do it on the other side of the L circuit, and we do it here at the relay. That's got a gain of 71, by the way. So we're tearing this all the way down because this guy just wants to put the best of the best of the best in this. 77. So these two are technically matched. We're going to do these two together as well. That's the closest we're going to get. Okay. Split capacitance tuning, bad. And I've seen it in messenger amplifiers. I've seen it utilized and I've seen it used by several different builders over the years. Because you got to remember, everybody's work comes here. This is the largest collection / library of amplifier knowledge on the internet in the video format, period. I've seen everybody's work, so I've seen it over and over and over again where people have tried that in the past. It never works out well. The box will run for a hot minute. Sometimes it'll run for a couple of years, but usually one of those caps will break down, devalue just a little bit, and it's enough to throw the entire circuit out of balance. So let's just have 1 point of capacitance added. And that allows us to really fine tune it at the relay, because from here, boom, it's going out of the cabinet. Where if we're trying to make our adjustment back here at the combiner, we still have all the inductor circuit, the actual induction of the combiner, and the wire length, and all of this other stuff that we're trying to compensate for here, where if we could just compensate for it in one spot, you're going to have a lot more stable circuit. Okay, I'm sorry I had to take that phone call. They're calling me to tell me my truck was finished and to come pick it up, which I'm super stoked and I'm glad to have it back. Let's get some transistors put in this girl. Okay, we're just checking in. Got the Toshibas down here. Got the input or the output transformers put in. 61 combiner with 2-to-1. Our 100 ohmers in place. We'll add capacitance here in a little bit, and now we're getting ready to drop in our input transformers. So let's get those soldered down. Let's get everything wrapped, and then we'll get some resistors put in here for flybacks, and then we'll start getting the bias set up. So just moving right along. Well, It's all done. The bias, no, it's not all done. I've got the sideband delay I have to add yet. So other than those couple little things that I had to change, all the amp, this is not that bad of a construction deal. I mean, it's got a good voltmeter on the front of it. It's got 3 decent power supplies in it. Are you effing kidding me right now? It does have a fuse, which I'm not gonna lie, lately I've thought was just kind of something that we did as a joke in the CB radio community. Because I've seen quite a few boxes here lately where there is no fuse. The minimal amount of safety is not taken into play. None whatsoever. So, it does have a fuse. It does have the appropriate size switch to turn it on and off. I like the giant toggle switch. It's awesome on the front. But this is done. Done. I never thought the day would come where I would literally say with a serious face, there's $1,000 worth of Toshibas in this thing. $1,000. But we're there. It's all properly biased. Now, what I am going to reuse from the original amplifier are these chokes. Because they are of quality and standard that we can use. But, I mean, there's some cool shit on this. Like, I'm really digging the back of this cabinet. I have a feeling that this is originally an ICA power supply cabinet. It's a small feeling. It's a fact. I do think it's a little weird that I can stick my finger all the way through the amplifier, though. What I mean by that is there's a big giant hole here at the back of the box. Now, what I don't get... Let's zoom in here. I'll turn up the gain so you guys can see what I'm talking about. What I don't understand is why we made an attempt to block it off but then stopped 2 inches short. So right now what happens with the single 120 millimeter fan, while it's running, air flows down, blows across the components, and then goes right out this hole and vents right out the side of this cabinet. Nothing goes over the heatsink. So tomorrow, I'm done for the day. I'm gonna go eat me some dinner. It's 1:30 in the morning. I'm done for the day. Tomorrow, I'm gonna block the cabinet off. I've got to fix this fuse holder. Whatever. Fix the fuse holder and the sideband delay. Test the input tune, output tune, and we're good. Till then, good night, goodbye. Done. We're gonna get to that in a minute. Okay. These are the HGs that came out. I want to test and see what this guy's got left over for parts here. It's got a gain of 11. It's got a little schmutz, it'll cause it to read bad. There we go. Gain of 12. Gain of 12. Dead short. So this is our problem bastard. We're going to just throw this up in the bag of forget-ems. Let's see, I didn't reuse these Torx screws, or those Allen screws. Set these aside. Come back to that later. Clean the jism off my fingers here. Okay, so we're completed over here. It's not the hottest box in the world, but it's electrically correct, and it's very clean in output power. Let me show you what I mean here. So I had to change a couple more things on top of everything else that we've changed so far. I went to go run this in our pass-through tune here. Otherwise, the RF's ability to come in, go down, go around, go through the racetrack of shit, and then come back out was way high. It was like silly high. Let's make sure the box is off. And standby. So this is a 5-watt slug between the 2950 bench radio and the amplifier, all the way down to the dummy load. I was sitting at 1.5 watts. How we had to compensate for that is we have to add capacitance down here at the relay, and that's this bank of capacitors here. This ended up wanting 165 puff worth of capacitance here. Added our sideband delay. This is our sideband bias relay. And of course, then we've got our sideband bias has been added. Type 61, type 61, type 61, and type 61, type 43. Okay, 43, 43, 43. And the end result looks a lot like this. Let's go see what we're transmitting and where. So first let me show you the radio. That's our input signal. So that tells us that everything that's going through the amplifier or going into the amplifier is going out on frequency. That's the amplifier. Radio, amplifier. Radio, amplifier. Modulated, hello, 1 2 1 2. That's what we're looking for. Once again, our watt meter is just the tool that tells us how much power we're putting out, assuming that it's on frequency. This is the tool that tells us where it's actually all going. This meter will read, and I say this because this is the second or the third time I've had to deal with one of these things. They look amazing on the watt meter, but over here it's scary because it's going out all over the place, and this lights up and looks like a Christmas tree, you know, like the ridgeline in a forest, just spikes all over the place. This just reads everything that goes through it. It doesn't discriminate what frequency it's on. I mean, it kind of does. Like this element is like 2 through 30 megahertz. Well, even this element doesn't read accurately, but it'll still register power up into the 80 to 150 megahertz range. It's not anywhere accurate, but it reads everything that goes through it and says, hey, it's all going through. But unless it's over here to where we can have it on a frequency that we're going to be able to use and our antenna is going to be happy with it, there's no point. So like I said, this isn't the hottest box in the world, but it's clean. I'll take clean over super hot any day of the week. No, clean and super hot together, that's okay. Hello, 1 2. We're down on 12 volts at the moment. So hello, 1 2. 18 watts or so going in. Hello, audio. Making 400 watts of power. Input reflect. Hello, 1 2. Hello, 1 2. That's really stinking good, in my opinion. That's not too bad at all. So, that's with the bias all running and everything. Now, I know the power supply is big enough, because watch our voltmeter. Hello, 1 2 1 2 1 2. When I measure it with the fluke, it's dropping like 0.3 of a volt. So right now the power supplies are set up for 15.1 volts in here. and they're dropping to 14.8. Now, what's going to happen when we start to pump it up? I don't know. Let's find out together. We'll do it together, just you and me. While we're here, I'm also going to cover the fact that now our giant air hole down here on the bottom has been thoroughly blocked off over here. Our fuse has been repaired and glued in place. So we got it tight, and then we glued the plastic nut in place so it can't back off. Details. All right. Now we're going to go to the bench Striker 955 made by Derail. Let's click that down. Let me show you the radio principles again. I don't know what this is going to look like on the Spectrum, but we're going to find out together. So 12 volts. Hello, audio. Now we're going to hit it with about 80. Hello, audio, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Seems a little low to me. Still clean here. Let's go and look at our input tune. 1 bar. Hello, 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 hello. A little bit high. Hello, 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 hello. Okay. So between this, hello, audio, and this, hello, 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 hello. I know I gotta do a little bit of tuning on this thing still. So let me continue playing. Okay, so Eagle case, built by Fat Cat, rebuilt by BBI, 4-pill Toshiba. Labeled your sideband delay. And then I went ahead and I took the liberty, and if you don't want it in there, that's fine. I went ahead and I took the liberty of putting the logo in here, so when you look through the lid, there's that extra fan hole. It's right underneath it, so take it out if you want. I mean, my man, it is your amplifier after it leaves here. So let's go over here. Once again, this is a 1,000 watt slug in peak power. Hello, 1, 2, 1, 2, 1, 2. That's what we're putting into it for drive. Here's the amplifier, nice and quiet. Hello, 950 watts, somewhere in there. Hello, hello, hello. Beauty. Input tune's good. Hello, right out around 1,000 watts. And it'll run like that all day. Nice, clean, smooth, happy goodness. So let's reach up here on our radio. We're going to go and we're going to put it in sideband mode. And we're going to reach over here and we're going to flick that into sideband mode. And now what we're listening to, we're not really paying attention too much to the watt meter. It's going to rig around the same amount of peak power. Average number is going to come up. What we're listening to is the relay. Hello, Kevin, Mark, John, and Smith. My name is BBI, and I am here to kick ass and chew bubblegum. Roger 10-4. Hello, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The sideband delay is a delicate thing. And either it's too fast or it's too slow. Oh, look at that, I just stepped on my German Shepherd. Come here, sweetie. Hi. Here, yeah, you were too close to Dad, and I stepped back and I stepped on you. Sit down. Sit down. Check this out. Digger-doos. Hey. Hey. Say hi to everybody. Yeah, sure. My purebred German Shepherd. Yeah, I got that from my friend Kenny and his daughter. They had 2 purebred German Shepherds, and my wife wanted a puppy. She was sitting too close to me, and I just stepped back and stepped on her little paw. You okay? All right, let's get back to the video. The relay delay is something special unto itself. If you want more delay, you add more capacitance here. If you want less delay, you take away capacitance here. And what we're doing is we're trying to save the relay contacts from arcing out, okay? And we want to hold that relay shut so that in between your words it's not going click, 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 click. It's just staying open long enough that you can carry out a normal rhythm of voice and have the relay stay latched. But then as soon as you unkey, you want to be able to receive right away, so you don't end up missing like the first half a second of conversation. So, well, Kevin and John, my name is Mark Smith, and I am here to tell you that I am dropping them all on channel 38 lower sideband, I think. And as soon as I stop talking, hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. This guy told me he's an avid sidebander. So I hope I guessed right on the sideband delay. Now if it was me, I'd put a little exterior RCA jack on this thing and make it so that you can use a foot pedal. Otherwise, eventually you're going to end up scrubbing your contacts off in your relay from them open and closing so much. But that's that. This thing is electrically correct, RF correct, got the right components in it, and all the right type of ferrite. I don't see you having any kind of problems with this whatsoever. The only thing I have left to do is put the lid on it and test the fan. And I just want to use my Ryobi impact, and I've always had a little bit of variable speed control on this thing. Now it's just full charge. Brand new. This thing's not even 2 months old. Garbage. Okay, so hello, 1 2 1 2. Oh, forgot to flip the sideband delay on. Hello, 1 2 1 2. 800 bird. It's impressive. Hello, 1 2 1 2 1 2 1 2 1 2. Audio. Audio, 1 2 1 2. Thing's barely even wagging, even on sideband. Well, gentlemen, this thing's got awesome airflow through it now. I'm telling you, it's chooching the chotch and chotching the chooch when it comes to air. So I consider this a win. I came in here a broken bag of beat down sadness and depressed dreams and wishes of being an amp, and leaving here a, well, fully functional, somewhat safer, probably electrically a little bit more sound piece of equipment. So, gentlemen, thanks. Big shout out to the Patreons first and foremost. I couldn't be here without all of them. Big shout out to Excess Power, Siglent, McMahon Alternators, of course, Bird Coaxial Dynamics. And I say thank every single one of you guys. I mean, literally, I'm giving my life to this hobby for you all. And I am standing here honestly saying thank you for letting me have that opportunity. I'll see you. Click, click.